Alright, in my previous example, we had vertical asymptotes. And we actually, from this end behavior model, we discovered, hey, I would have an end behavior model where my left and my right limit both approach 0. So I actually have a horizontal asymptote at y equals 0 as well. Alright, so let's see if that happens in B as well. Well, in B, I actually have a vertical asymptote as well. Alright, and why that happens is, again, we're going to factor that denominator. It is a difference of cubes, because 27 is a perfect cube and x cubed is a perfect cube, and difference meaning that subtraction is involved. Alright, so right now what I've got is a cubed is 27 and b cubed is x cubed. So a is just the cube root of 27, which would be 3, and b would be the cube root of x cubed, which is just x. So what I've got is actually a minus b, which is going to be 3 minus x, times the quantity of a squared. Well, if a is 3, then a squared is 9, plus a times b. Well, a times b is just going to be 3x, plus b squared, which b squared is just x squared, as that factors. Okay. And then I've got that all over. Probably should have moved that down slightly so it doesn't look like the bx is all up in there, and so I did. So I've got that 4x cubed still up top. Alright, so the first thing I notice is that this is going to factor into imaginary parts, which is why there's not multiple x-intercepts other than just this particular part here passing through. But other than that, I do notice that my vertical asymptote is at positive 3 because this particular factor is going to give me a real solution. So if I say 3 minus x equals 0 or cannot equal 0, I would get negative x cannot equal negative 3. Therefore, x cannot equal 3, which is where that vertical asymptote comes from. Which means the other thing that I'm going to have to mess with is going to be a vertical asymptote. Yay, we could have told that from the graph, but if we didn't have the graph there, that's how we would have said, hey, I need to know what the limits from the left and the right look like. But to be honest, I'm probably going to give you a graph. Let's be honest. Alright, so my end behavior model on this one, just like we did on the last one, my end behavior model would just be telling me, hey, what's literally going on the ends of my graph on the left and the right. That's what that does. Well, my end behavior model is, again, just where I'd look at the lead two terms, which in this case would be 4x cubed over negative x cubed. Again, lead two terms, even though it's not written as such. You would have to write it in standard form to figure out what those are. Simplifying that out, my x cubes cancel out, leaving me with just 4 over negative 1, which is overall negative 4. Well, guess what? That end behavior model tells me that I have that horizontal asymptote at y equals negative 4. Cool. Whoa. Computer glitch, but that's okay. So I've got a horizontal asymptote at y equals negative 4, which also means that my limit as x approaches negative infinity, which means that I'm going to the left. So as my x values go to the left, what's happening to my y values? Well, my y values are getting closer and closer and closer to that horizontal asymptote, which is at negative 4. And my limit as x goes to the right, aka positive infinity, well, as I'm going to the right, which is this piece here, it's also approaching that horizontal asymptote, which is at the y value of negative 4. Cool, there's that part. But we also talked about, hey, I've got this vertical asymptote, which is also going to be important. So I've got a limit as x approaches 3. Well, again, I've got two different values approaching 3. As far as y values go. So as I approach 3 from the left of that asymptote and to the left of the x value of 3, my y values are going up and up and up forever. So from the left, so I indicate that with the minus sign again, and my y values are going up and up forever, meaning that it indicates that it's going towards infinity. Alright, and likewise, I've got x goes to 3 also from the right. Well, from the right, I'm going to be looking at this piece here. and saying, okay, well, what's this piece doing as it's approaching 3 from the right? Well, it's going down and down and down and down and down forever, which means that it is approaching negative infinity in that case. And with that, I would be done. Cool. Okay.